तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
In the last lecture we have just looked at the basic two phase commit protocol. We just stopped at the point where we just had the basic protocol and how it works. Actually two parts there, one part is the participant protocol and the other is the coordinator protocol. How the coordinator protocol is working is the coordinator starts with sending a prepared message, and once he sends a prepare message from the initial state, he actually reaches the state where he is now undecided. So, the prepare message is sent to all the participants. Once the prepare message has been received by the participants, they will reply back with a ready message to the coordinator. If the coordinator actually receives all the ready messages, then he will take the commit and he will send the commit message, then the coordinator will reach the commit state, and if he receives any of the participant actually says he wants to abort, that means for the prepared message he gives an abort answer message, then you are going to actually take an abort command message, and this state actually the coordinator reaches the abort state. It is also possible for the coordinator to reach the abort state if it times out, that means he does not receive the message from the participant, then one of the participants has failed. Since one of the participants has failed, you are bound to actually take an abort message, right. This is the basic part of the coordinator. As far as the participant is concerned, that is each participant site for the two phase commit is concerned, each participant starts with an initial state. Now he is going to get a prepare message. In response to the prepare message, he can basically give a ready message. Now when he gives the ready message, he is in the basically the ready state. When he is in the ready state, now wait for the coordinator's decision. If the coordinator actually gives the abort command message, then you are going to acknowledge and then reach the abort state. Because even after you actually replied with a ready message, it is possible the coordinator can still take a abort decision, because in that particular case the other participants may not have replied back. Unless he gets all the ready messages, he can't commit the transaction, right. Now in the other case, all the participants replied with ready message, the coordinator is going to send the commit message, in which case the participant actually commits and then sends an acknowledgement. That means he has written all the values onto the database. This is the basic two phase commit protocol that we have seen in the last lecture, and where we have just stopped is just explained this protocol and then said that what happens in terms of different failure scenarios. We thought we will look at it in the next class. That is where we stopped in the last lecture. Now there are several things that can happen in this basic protocol. For example, coordinator can fail in the first phase or the second phase, participant can fail in the first phase or the second phase, network could fail, which means that it is possible for the various nodes to get partitioned. There are some nodes in one partition, some nodes in the other partition. So all these are possible scenarios as far as this protocol is concerned. Now one of the things we are going to look at it is what are the cases where this protocol is resilient, which means that which are the failure scenarios where this will still work correctly. Okay. Now let us first take the case where so we are going to look at different cases of failures. Now the first kind of a failure is a participant fails in phase 1. Okay. What happens if the participant fails in the 2 phase commit? We are talking about the first phase. Okay. Now what happens in this case is the coordinator will time out, and then once the coordinator times out, he is going to take the decision of aborting or sending an abort message here. For example, here the coordinator is going to time out, and then he is going to, in that response he is going to take an abort message, abort command message the minute actually one of the participants has not replied. Okay. So I think that is, so in this particular case the coordinator will time out and then take a abort decision. Coordinator will time out, as a result he is going to take an abort command message. Okay, that is what is going to happen when participant fails. So obviously 2 phase commit is resilient for participant failures in the first phase. Now what happens if the participant fails in the second phase of the participant fails in the second phase? That means in the first phase the participant has replied with a ready message, which means that he actually replied with a ready message, and now he is waiting for the coordinator's decision. Coordinator can take either a abort decision or a commit decision. Now if we say that the coordinator has taken an abort decision or commit decision, you have to, after recovery you have to check with the coordinator, and accordingly you have to do. As far as you are concerned, you have replied with a ready message. That means you actually now written all the logs, and you can't release any of your logs or any of the resources till such time you know the decision of the coordinator, right. So in this particular case you are going to wait for the decision of the decision. Now since you are waiting for the decision, since you have failed waiting for the decision, all that you have to do is after recovery, that means after you recover from failure, after recovery the participant should check with the coordinator. Participant checks with the coordinator for the decision. What happened about this transaction? He has to check with the coordinator, and accordingly he has to terminate the transaction. That means based on what the coordinator tells now, coordinator need not wait for this participant because it is already replied with a ready message. So in this particular case the coordinator is free to choose now a decision depending on ready message, or if he gets all the ready messages then he can take the decision to commit the message, commit the transaction, in which case a commit decision would have been taken. So that participant has to find out now what happened to this transaction, and he has to do accordingly. One of the things is here, neither other participants will be blocked because of this participant failure, nor the coordinator will be blocked. All that the coordinator has to do is write the decision of this, and when the participant comes back he has to tell the participant about this decision, and once he gets acknowledgement from the participant he is going to write the final log on this transaction saying that it has been successfully completed. Only that is a thing that needs to be done in this particular case. Now, it is possible also for the failures to happen for the coordinator at different phases, and they are also possible that both coordinator and participants can also fail, need not be just failures of participants alone or coordinator alone. But right now what we looked at it is what happens if the participant fails, one or more participants fail in the first phase and the second phase. So, if you want to look at what happens to the coordinator failures, suddenly you have to now understand in which phase the coordinator has actually failed. Again we can see the case where coordinator failed in the first phase. If the coordinator actually failed in the first phase, that means he sent the prepare message and after that he has failed. So, he has not actually taken any decision on this transaction, and then he failed before the ready messages have actually arrived at the coordinator. So, coordinator has not reached a decision, but then after sending the prepare message he failed, the coordinator has failed. Now, the way to recover from this is simple. All that the participants have to do is they have to elect a new coordinator and then restart the protocol. That means the new coordinator will now send the prepare message and then correspondingly he will take the decision about the transaction by running the two phase commit protocol again. So, in this particular case a new coordinator is elected, assuming that there are no failures, new coordinator is elected here, and then the transaction is restarted, that the two phase commit of the transaction is restarted, that protocol, and then based on that the commit protocol will be executed based on this. One of the assumptions that we will be making here is that all the participants are live, they are not dead. But then if they are, if it is not the case also, what will happen is the new coordinator will be elected and he will time out when he starts the protocol. So, he will make an abort decision. Okay. So, in that sense the protocol becomes re-entrant, that means any number of times any number of failures occur. For example, you elected a new coordinator, now that coordinator fails again in first phase, then you are going to again have the election algorithm to elect a new coordinator. Okay. This is basically protocol is very simple. Now, in the other case, if the coordinator actually fails in the second phase, this is an interesting problem. Actually, the very fact that you are saying that the coordinator actually failed in the second phase means that he has taken a decision, right. Now, it means that decision has been taken, decision of aborting or committing has been taken. Okay. Now, one of the conditions that can happen here is has this decision been known by other participants, okay, which we can say now there is a case where at least one participant knows this decision of the coordinator before he failed. Okay. So, the scenario 1 is here is one of the participants received, one of the live participants, which means that he is actually live, and then he actually received this decision of the coordinator. Live participants, okay, received the decision, which actually means that all that you need to do in this particular case is, since the decision of the coordinator is known, the same decision can be conveyed to everybody. So, if it is a commit decision, everybody will commit, if it is an abort decision, everybody will abort. Okay. Right. So, it is a very simple case where the decision of the coordinator is already known, the coordinator fails, some participants did not receive this decision, all that they have to do now is find out if any of the other participants have received the decision of the coordinator. If they have, then it becomes a simple scenario where that decision can be implemented by the other participants also. In this particular case it becomes non-blocking, that means nobody is actually blocked. Okay. This is very important, you are not now waiting for somebody to recover back. okay, right. For example, if the shooting is happening and our recording person decides to go out for a tea or something, then we are all blocked till such time he comes back, that is a blocking protocol. You do not want things to be blocked, you want actually, even if he goes and he puts it on an automatic mode and goes off, then we are not blocked, we can continue our job. Okay. So, in a similar way, even if one of the coordinators fails, okay, and it still none of the participants need to wait for this coordinator to recover back from that failure, it is a very nice thing and it is a very simple case, that is how we want to actually model our protocol. We do not want any other participant to suffer because of this failure. Suffer means he has to wait now, and you do not know when that recovery is going to happen. So, you get indefinitely blocked if such a thing happens. So, one of the all the cases we have seen so far, two phase commit protocol is non blocking, it does not block anybody. Okay. Now, there is a interesting case that is going to come now, where we can see the case where, okay, the scenario 2 where the coordinator failed, none of the live participants know about the decision of the coordinator. Okay. But again there are going to be two sub cases here. Okay. Now, we can say decision of the coordinator is not known. Okay. Coordinator is not known. In this case, it is possible that all the participants are live, that means there is no other participant failure. Okay. That means only coordinator has failed, the decision of the coordinator is not known, but all the case where this is only first case, this is not the second case. Okay. First case where all the participants are live, that means there is no participant failure, all the participants are live. Okay. In this particular case, since all the participants are live, a simple thing they can do is they can restart the two phase commit protocol by electing a new coordinator. In this particular case, you will elect a new coordinator and restart the two phase commit protocol. Okay. You are going to see is the case where if you say that the two phase commit, the participant also failed along with the coordinator. Okay. Right. So, there is not only a coordinator failure, but there is a participant failure, which means that now the rest of the people, the interesting case is here, imagine that the coordinator took a decision of committing and that is known only to this participant, and he actually wrote all the values on the of the database, and then he actually failed. Okay. Now, if the remaining participants now elect a leader coordinator and then terminate the protocol, it might contradict if the earlier coordinator already taken a decision and that is known to this participant. There is no way to recover back from this. So, basically this is the case where all the other participants, in this particular case all the live participants will be blocked. Okay. All the live participants are blocked till such time the coordinator recovers. You can't do now anything except to wait for the coordinator to recover, wait for coordinator to recover. Okay. Now, often a coordinator failure also means a participant failure, because the transaction where it is started, normally coordinator is one of the participant sites. For example, if you basically look at how the transactions are started, one of the sub transactions where the where it is getting executed, he will also take up the responsibility of being a coordinator. Normally coordinator failure will be equivalent to a participant failure, and that is a scenario where two phase commit will not be able to recover back, and this is an important case. Normally you do not have a coordinator failure normally means a participant failure. Only thing is, if it is failed in the first phase, then you are a bit lucky, because in that particular case the remaining participants can elect a new coordinator and make a decision. But if actually failed in the second phase, phase 2, after actually sending the ready message, you discovered that the coordinator has actually failed, you will be in trouble, because you will not know whether the coordinator has taken a decision or not taken a decision. So, that is a case where the participant is forced to wait till the coordinator recovers back from this failure. Okay. Now, having explained this, what we are going to see is how this protocol gets modified to also allow the protocol to recover in the case where the coordinator fails in the second phase along with the participant, and that modification is what we see as a 3-phase commit protocol. What the 3-phase commit protocol does is, intuitively to understand what the 3-phase commit protocol does is, when the coordinator actually failed, you will not know what is the state in it, state in which the coordinator is, and this is very important in distributed systems. This is a typical problem that you will face in distributed systems. You need to know the state of the other node when things have actually failed or when the system crashed. If you know the state of the system, it is easy for you to recover back. But now if you do not know the state of the system, then you are in trouble in terms of recovery back from the recovering from that particular failure. Now, in this particular case, when the coordinator actually failed, you will not know whether it has taken a commit decision or an abort decision. Now, what you want to decide now is, or want to see is, what is the state in which it is. To actually get out of this ambiguity, you are introducing a 3-phase. That means the coordinator will not directly get into the phase of committing. If you carefully observe, the problem is in terms of moving coordinator moving directly when it gets the ready message into the commit state. If you actually record in between a state where the coordinator says that now I have received all the ready messages, now I am prepared to commit, okay, he is still not committed, but then now you introduce a prepared to commit state for the coordinator, which means that now you know whether the coordinator has reached a prepared to commit state or not. If he has not reached the prepared to commit state, then no harm done, because he failed in the second phase, but then only in the third phase actual commitment would have taken place, right. So, basically you need to know the state of the coordinator when he actually died or when he failed, So, in that, to remove that ambiguity, you are going to introduce now a third phase, and that is where basically you get the 3-phase commit protocol. What we are going to do now is we are going to see how this gets modified for the 3-phase commit protocol, or how the 3-phase commit protocol works, and then also look at what kind of failure scenarios the 3-phase commit protocol can tolerate, or it is resilient to what kind of failures. Now, what we are going to do is, for both the participant as well as for the coordinator, we will introduce a new state where they have to first get into the before commit state or prepared to commit state before they actually commit. They cannot directly get into the commit state from the ready state. Now, the coordinator part is going to look something like this. Now, I will start with an initial state, and now as usual I will send a prepare message to all the sites, then I will basically reach the undecided state here, because I have still not decided on the state. But now if I basically get all the ready messages, then I will actually enter what I call as a before commit state. I have still not committed. So, I basically reach a before commit state here. Now, once I reach this state, before commit state, and I receive acknowledgements from all the participants, then I take the commit message. That means, I get an OK from all the participants, then I will issue the commit message, and then I reach the commit state after receiving OK from all the participants. Now, it is possible for me, for various reasons, to move from before commit state to an abort state. If I do not receive OK from all the sites, I can still end up in a abort state. As usual, I can also come to the abort state if there is an abort acknowledgement message, answer message from one of the participants, then in response to this, as usual, I will take the abort command message. It is also possible through a timeout message I might reach the abort command message. Okay. Now, this is the diagram for the coordinator. State diagram for the coordinator looks something like this. Okay. The participants state diagram in the 3-phase commit will look something like this. The participant will be initially in the initial state. When it receives the prepare message, it will reach the ready state if it is willing to commit the transaction. So, in that case the participant will reach the ready state. In case it is not willing to commit the message, then it will answer with an abort answer message and will reach the abort state. From the ready state also it is possible for the participant to reach the abort state if it receives an abort command from the coordinator, in which case it is possible for the for the participant to actually reach this state if there is an abort command message, and then the participant reaches that state through the ready state. If the other participants are not willing to commit, the coordinator can take the decision to abort the transaction, in which case the participant will move from the ready state to the abort state. If all the participants are ready to commit the transaction, which means that all of them have actually responded with a ready message, then it is possible for the coordinator to take a commit decision, in which case in the 3-phase commit he will initially enter the state called the prepare to commit state, which means that he will send the prepare to commit message to the participant. When the participant receives the prepare to commit message, he will reach the prepare to commit state. Now, when he reaches the prepare to commit state, he is still not committed the transaction, he is waiting for the final decision of the coordinator. When the coordinator receives OK for all the prepare to commit messages, then he will actually issue the commit message, that is the commit instruction, in which case the participant will reach the commit state here. This additional state is needed because it is possible that if the coordinator fails, after one coordinator and one participant fails after reaching the prepared to commit state, it is still possible for the participants to elect a new coordinator, in which case it is possible that a decision to abort could have been taken by the new coordinator, in which case after coming back from after recovering from the failure, it is possible for the participant to move from the prepared to commit to the abort state. Now, this is the participant state diagram. We look at the actual failure scenarios here. Okay. Now, the case where the failures can occur, as usual the participant failing in the first phase or second phase are similar. Similarly, the coordinator failing in the first phase is also similar. Only the case where we need to relook at is the second case where the coordinator actually failed, that is what we had recorded there. That means there is a coordinator failure in the second phase. Okay. And then there is also one participant failure, okay, or we also have a participant failure here. This is the case where we have a problem earlier. Now, let us examine this case and see what happens in this particular case in terms of how the recovery takes place in this particular case, as the coordinator fails in the second phase along with the participant. Now, in this particular case there is going to be a third phase obviously, because the second phase is not the last phase. Now, if the coordinator, nobody has received this decision from the coordinator, obviously at most the coordinator is likely to be in the second phase, which means that the participant here could have been in the prepared to commit state. Okay. Prepared to commit state, it has not actually committed. Okay. So, at most this state can be prepared to commit, it cannot be commit state. The coordinator also would have been, this is for the participant, okay, this is the state of the participant, okay, can be this. Now, the state of the coordinator can be also before commit state. Now, if these two are in this state, the rest of the participants can still now elect a new coordinator and still go ahead with the protocol, because they have still not committed there, okay, they have not committed the transaction. Okay. Now, in a simple case where the coordinator actually passed the second phase, okay, now imagine there is going to be a sub case in this particular case where the coordinator has passed into the third phase, that means he failed in the third phase, not in the second phase. Okay. Now, this becomes a very simple case, coordinator fails in third phase. This is a very simple case because the coordinator actually taken a decision to commit, and this is actually conveyed to all the participants, otherwise he would not have got himself into the third phase, because unless everybody replied for the prepared to commit state, he will not reach the third phase of actually sending the commit message, which means even if one of the participants have received it, then only it is clear that it has actually moved into the third phase, otherwise it is actually not moved into the third phase. So, in this particular case it is easy for you to just commit the message, because you know the decision of the coordinator that it has been actually committed. Okay. So, this ambiguity of not knowing the coordinator state when it has actually failed is taken off in the case where the state of the coordinator is known by introducing an extra phase where the participant and the coordinator directly do not commit, but they actually reach a before state, before commit or before prepared to commit state before actually committing, and that is how this ambiguity is actually resolved, and that is how the failure is handled by introducing an extra phase for commitment. Now, one of the interesting things is how is this leader election going to happen, because every time you are actually seeing that if the coordinator is failing, it is equivalent to actually some kind of a leader election algorithm, because you are actually electing a leader whenever there is a coordinator failure, you are actually doing a leader election. Okay. In a simple way, the leader election can be done by assigning in terms of each participant or each node, okay, an ID, okay, and these IDs could be in an ascending order. Obviously, every node is going to get a unique ID here, that means there is a unique ID each node is going to get, and you can actually assign, okay, at any given point of time a simple way assign the highest or the you can use the least node ID or the highest node ID. Okay. So, basically you can assign the live node, okay, with least ID, okay, as the leader. However, this is not simple, because now we have to actually find out whether you should take over as leader, because somebody has to detect that the coordinator has actually failed. That means what really is going to happen is, if a participant discovers, okay, it is only going to be the participant who is going to discover that there is a coordinator failure, because he is waiting for some decision of the coordinator. That is how the participant will discover that there is a coordinator failure. So, what happens is, if a participant discovers, okay, who it can be anybody, a participant discovers that the coordinator has failed. Now, what he needs to do is, he has to do an extra, okay, if he basically discovers that there was a failure of the coordinator, then he has an option of now finding out, or he has to do this process of finding out who is the next highest or least node that is still live. Okay. So, he starts now looking for the next possible highest least node, live node, and tries to make that node, okay, as the coordinator, but then that node also would have discovered that the coordinator would have failed, that participant. So, basically all that it needs to do is, it has to see whether it is the least node, live node, and if it is so, basically it now elects himself as the coordinator and starts running the recovery protocol. Okay. So, in this particular way, any number of coordinator failures are tolerated by this protocol, because all that a protocol has to do in this particular case is make a participant, whenever it discovers that there is a coordinator failure, figure out the next highest or least node that is supposed to take over, and if it is its turn to take over, it will basically become the coordinator and tries to run the protocol. Okay. Now, there are two ways this can be further achieved in terms of how this protocol can be run by the coordinators. One of the things, properties that we need to ensure for this protocol is a re-entrancy of the protocol. That means, the protocol can be run any number of times. That means, a coordinator fails, then a new coordinator takes over. Now, while running the algorithm protocol, that coordinator could also fail, which means that now another coordinator has to be elected and he has to take over, and this should become re-entrant. That means, any number of such failures should be possible when you are actually recovering from the failures, in which case basically the protocol is called re-entrant protocol. That means it is tolerant to multiple failures of the coordinator any number of times. Okay. So, it becomes a re-entrant protocol. Now, there are two ways this re-entrant protocol can be configured. One is a proactive way of actually making it move forward. The other is basically a pessimistic way of re-entrancy. Okay. In a simple way, what the coordinator can take as a decision is, if the coordinator is in a state of before commit state, okay, he will basically whatever state he is in, he basically enforces that more or less on the other people. Okay. Let us understand this point a little carefully. The coordinator has failed in the first phase, which means that no decision has been taken by the coordinator. Now, a new coordinator is in place. How this new coordinator should start the protocol? Okay. Now, new coordinator realizes that obviously the new coordinator is not likely to be in any other state other than the first phase, because he has not received any message from the coordinator. So, he is going to run the entire protocol starting from the first phase. Now, he actually initiates the prepare message to other participants, receives the ready message, then gets into the second phase, then goes into the third phase and things like that. Okay. Now, the way the new coordinator can further improve the protocol is, whatever state he is in, okay, he can actually find out if there is any other participant who is in a before commit state, which actually means that now we can actually need not restart the protocol, but then he knows that actually the decision of the earlier coordinator is actually to commit the message. Now, you could actually, when there is a before commit state, it is possible for the protocol to terminate as an abort, because the new coordinator now ignores this decision, but then just conducts the sends a message to all the participants. Now, some of them are not going to reply back to him, then he can actually end up with a abort decision. But it is quite possible for the new coordinator to find out if one of the participants has reached a before commit state, in which case actually he can force the protocol to a commit state. Okay. To just explain this a little more probably in using our diagram, you can see here the coordinator actually, the new coordinator who was elected. Now, if he basically did not receive the prepare to commit message, which means that he will be in a before state, he still not received this message, which could have made the whole protocol terminate at the abort decision. Okay. Now, if he actually checks with the other live participants and at least one of them has actually received this PCM state, but it is not the new coordinator, it is some other node has been elected as a coordinator now, then it can still take a commit decision, because everybody would have reached that state. So, it is possible for you to, because unless all of them have replied with a ready message, this state would not have been reached, right. Now, the new coordinator can take a decision to commit the transaction and then make it So, basically all that will be required for the new elected coordinator in this case is not only check his state, but then check the state of all live participants, and based on that restart the protocol at an appropriate point. It is done like that, the re-entrant protocol terminates in a forward direction in terms of committing. Wherever there is a possibility for the protocol to commit, it will commit, rather than always ending up on the abort state depending on the state of the new elected coordinator. So, these two approaches are possible in terms of recovery from the failures as far as the coordinator is concerned. I think what we are going to do in the next few minutes is not only look at this scenario of failures, but then also introduce now the concept of what happens with a network failure, because you are now talking about only node failures so far, we are not talking about network failures as part of the recovery process. Now, in terms of network failures as far as the protocol is concerned, the two ways of actually interpreting a network failure. Network failure actually means that the nodes are not reachable. Okay. So, let us take for example a node here, this node could be a Chennai node and then this other node could be Delhi node. Okay. Now, all that you are looking at in terms of this system is both of them are connected by means of some let us say backbone network. There could be several links involved in connectivity between these two nodes. All that you have is basically a network which is actually providing this connectivity. Okay. Now, when the network actually fails, in a simple case this actually surfaces as a timeout on the other side, because that is how actually you are going to discover. Okay. You are waiting for a reply and this scenario actually comes as a timeout in our diagrams as we saw there, and the timeout could be a possibility because the network has actually failed, not the node has failed. Okay. In either case you will not be able to detect the difference between a network failure and a node failure, because the node, as far as for example this Chennai node is concerned, it does not receive the reply in time from the Delhi node. It could be a network failure, it need not be a node failure. The node could be still live and could be kicking, could be doing some work there, but when it actually sends a message, let us say a ready message, the Chennai node did not receive the ready message. This is equivalent to actually a node failure. That means network failure in some sense actually translates to a node failure. In a simple case this translates to a node failure. Okay. But then it is probably not appropriate to just consider a network failure as just a node failure. In our case it still works, because when the timeout actually has reached on the other side, all that you are assuming now is the decision of the node is to abort. Okay. So, nothing, no harm is done in this particular case, but then what could have been a positive thing still ends up in the negative side, because you could have still committed the message because the node has still responded with a ready message, but since it did not reach the other node and it decided that when it did not have any information, the best thing that it can do is to abort the message or abort the transaction. That is what actually it assumes and then aborts. So, basically a network failure and a node failure in a normal case both appear to be can be treated in the same way, right, and that is how these protocols, both 2-phase commit and 3-phase commit, are resilient to network failures in terms of translating them to the participant failures. Okay. But one has to be careful when the network actually fails, but then that failure is not just to one failure of one node, but it can result in not able to reach multiple nodes. Okay. So, typically this scenario is a very simple case where it has been translated into a timeout case, but then assume that a network failure actually results in multiple nodes not being reachable. Okay. Now, let us imagine we have a node in Chennai. Okay. Let us say this is Chennai node, and then we have actually a Bangalore node. Okay. And then we also have Mumbai node here. Okay. and then we have one of Delhi. Okay. Now, it is possible that a network that is actually connecting them, let us assume that there is a complicated network here which actually connects the all the nodes with one another, but then if there is actually some kind of hub that connects the southern nodes together and the northern nodes together, it is quite possible that this hub actually failed, which means that these nodes are still can reach each other in this direction and these nodes can still reach each other in this direction. Okay. Now, assume that Chennai is the coordinator. Now, as far as Chennai is concerned, the whole problem translates into the failure of both Mumbai and Delhi, because it still is reachable. Bangalore is still reachable, and let us say it replied with whatever required messages. So, this basically results in partitioning of the whole set of nodes. Now, we have actually two partitions. There is one partition one here which consisting of Mumbai and Delhi, and there is another partition 2 consisting of Chennai and Bangalore. Now, it is if you carefully look at this scenario and try to understand what could happen in this particular scenario, it is possible that Chennai and Bangalore could start detecting that there is participant failures, which means that two participants have failed and two phase commit is resilient to participant failure. So, what they basically do is, depending on which phase you are in, you might end up actually making a decision about the transaction. Okay. So, this basically these two might try to run the two phase commit protocol, saying that there are two participant failures. Now, as far as Mumbai and Delhi are concerned, okay, for them it translates to one coordinator failure and one participant failure. They also try recovering back from this problem by saying that now they will have a new coordinator depending on what phase they are in and how they should be handling this problem. They might actually try recovering back from this failure. Okay. Now, in this case it is possible that the decisions of the two partitions need not be consistent, and this is happening mainly because the network the nodes are not realizing it is a network failure, they are seeing them as failures of the participating nodes. The participating nodes are still live and they are working. So, for each one of them the scenario is different. Unless this is discovered that it is a network failure, not a node failure, you will not be able to actually make a distinction between a network failure and a node failure. And this really results in a very complicated situation where even if you use a 3 phase commit protocol, where the network actually partitions the nodes into multiple partitions, you will not be able to recover back from the problem. In other words, what we are making an assumption here is there is no partitioning that is happening. If this is the case, no partitioning of the nodes, and this is an assumption with which you are actually working on the 2 phase commit protocol. If the network partitions, you have the problem of recovering back from the failures, because all the cases which we discussed and which we looked at are actually taking them as participant failures, and they are not really participant failures, and it is a network failures, you basically will have a difficulty. An interesting assignment could be, what are those cases where the network partitioning can lead to problems, which is the case in which the protocol, the states of the coordinator and the participants, in which case the partitioning could really create a problem. The other thing is to discover if you are the majority partition, probably if you are the majority partition, probably you can still go ahead and do something, which means that you have to first discover that the system has actually partitioned and whether you are the majority partition, and based on that you probably can recover out of the failures. It is still a very open ended problem in terms of how one can recover from network partitions. It is also interesting to see how one can make a distinction between network partitions and node failures. For example, one way is to actually, if you just do a ping, you only know whether the node is live or not. Okay. So, that still remains a very interesting problem in terms of seeing how one can make a distinction between a node failure and a network failure in a distributed system. Right now what we have seen is the basic commit protocols. In the next class what we are going to see is how these commit protocols can be integrated with concurrency protocols. For example, how the two phase locking can be integrated with two phase commit protocol. That is we are going to continue with the next class.